Given functions f and g, we want to determine the composite function f of g of x and also g of f of x. For the first step, let's rewrite this in the form of f of g of x. This form is going to be easier to work with. And we'll write g of f of x in this form here. So we'll start with the inner function. Notice there's no input into function g, so we're going to replace g of x with 3 divided by x minus 5. So we can write this as f of 3 divided by x minus 5. And now this becomes the input into function f, so we'll substitute this quantity for this x here. And this will give us our composite function. We'll have 1 divided by the quantity 3 divided by x minus 5, and then we still have plus 5. Well, this actually works out pretty well because notice how we have minus 5 here, plus 5. That would be 0. So this simplifies nicely to 1 all over 3 over x. Remember, this fraction bar means division, so if it's helpful, we could write this as a multiplication problem. This would be 1 times the reciprocal of 3 over x, which would be x over 3, which of course is just x divided by 3. So our composite function, f of g of x, is equal to x divided by 3. Now let's take a look at g of f of x. Again, we'll start with the inner function f of x. And there's no input for function f, so we're going to replace f of x with 1 divided by the quantity x plus 5. So this is equal to g of 1 divided by the quantity x plus 5. And now this becomes the input into function g, which means we'll substitute this quantity here for the x in function g. So this is equal to 3 divided by 1 all over x plus 5, and then minus 5. Now for the next step, this is 3 divided by this fraction, which is the same as 3 times the reciprocal of this fraction. So this would be 3 times the reciprocal of 1 over x plus 5 is just x plus 5. And then we still have this minus 5 here. So now we'll distribute. This would be 3x plus 15 minus 5, which is equal to 3x plus 10. So g of f of x is equal to 3x plus 10. I hope you found this helpful.